first we're going to draw the components for this circuit. So we can see that we have 6 resistance. So we're going to place them. So we have resistance 1, resistance 2, resistance 3, 4, 5, and 6. Now we're going to assign the values for the resistance. So we have 14 ohms, 10 ohms, 15 ohms, 21, 20, and 53 and 17. Now I'm going to rotate the resistance so they follow the path of the circuit. Now I'm going to place first the independent current and voltage sources. So first the independent current source, so it's going upwards and has a value of 2 amperes. And for the independent voltage source, the positive is here, and it has a value of 5 volts. Now I'm going to place the dependent currents and voltage sources. So here we have a controlled controlled current source. So we have this one, and it's going upwards. And we can see that this current depends on the value of I1, IY, which is following this path. So IY is going to be multiplied by 5, and that is going to be the value for this current source. So we're going to apply this value, so it's 5IY. And finally, we have the voltage controlled voltage source, which positive is going to this side. And we can see that this source is going to depend on Vx, which Vx is going through this resistance, and we can see that Vx is going to be multiplied by 10, and that is going to be equal to this voltage source. So this voltage source is going to be Vx times 10.
So now we're going to do all the connections. As we can see, we're going to connect here the resistance 1 to the resistance 2. We're going to connect the resistance 1 to the source dependent, the current dependent current source. We're going to connect it also to the resistance 3 and also to the resistance 5. We're going to connect the resistance 5 to the voltage dependent voltage source. I'm going to connect that to voltage, the resistance 6, and to the voltage source. We're going to connect the voltage source to the resistance 4. I'm going to connect the resistance 4 to the current source. We're connect the current source to resistance 2 and resistance 3 to resistance 6 and to resistance just here in the node in the middle of it. Now we're going to make the dependent sources work. As we can see in the diagram, we're going to try to connect Vx, which is the positive polarities here and the negative here. And as we're going to have to measure voltage, we're going to measure it in parallel. So we're going to connect the positive polarity here and the negative polarity here. So it's in parallel, doesn't affect any of the calculations, and gets an accurate reading of it. We're going to make it a little bit more visually appealing. And now we're going to connect in the current. As we know, as we can see, the current is flowing in this direction. So we're going to separate this node and we're going to connect it in series. As we know, in series, the current doesn't change. So we're going to connect this point to this, so it follows the direction of the current. And we're going to connect it all the way back to the circuit. In this way, it will not affect any of the measurements, and we're going to get an accurate reading of all that we're trying to get. Now, we're going to put these checks So we can see if we build it right and it's accurate to our measurements. We're gonna flip the direction, so as we did it, is counterclockwise in our measurements, so it gets the same results. We're gonna put all of them here and here. And just some voltage to see if the voltage dependent voltage source also got the same results. And as we can see, if we do the animation that we're gonna put the ground, so it gets an accurate calculations in the middle node, we can see that it gives us the same results that we got when we made all of our calculations.
So my name is Eva Fernanda Ortiz, and in this part of the video, we're going to try and solve this circuit using nodal analysis and using the software Tina to corroborate our results. So first off, we start off with selecting every component that we have. Here we have two voltage sources. We have some resistors or resistances. This one's going to go in here, this one in here, this one in here, and another one in here, and another one in here. This looks all messy right now, but in a moment, this will all make sense. And we have a current source that's going in here. Now we need to adjust everything because it's a mess. Our voltage sources need to be towards facing the same polarity that they are facing in the diagram that we have. So this one should be looking towards that side. This one should be looking again towards that side. This current source, the same as a voltage source, should be facing upside, like this. And this resistor should face in this direction. We can adjust the labels here. Yeah. And to set everything, we need to adjust the parameters. For example, this one says that it's 8, it should be 16 volts. This one says it's 6K, it should be 2K. And like this for every parameter we have. This one's okay, this one's 8. Oh, this one also should be rotated like that. This one's 8K. This one's 1 milliampere, and that's okay. This one's 6 should be 3K. This one's 6K, and that's okay. And finally, this one should be 2K, and it's 6, so we should change it. I think that we're all set now. Oh, yeah, now final adjustments, final touches, yeah. These are all the independent components, but as we can see, we have here current depending voltage source. And for this to be represented on our software, we go in here in control sources, we select current controlled voltage source, which is the one we have, and we place it where it should be going. This one will automatically multiply the value of the current that's flowing in this parameter. We have in here that this current is the one that's depending on, and this is the amount of times that it's going to be multiplied. And we have here that it's 4, so it's okay. Now that we have this, we can start making the connections with our pencil. That's going to be like our cable. This one goes in here, this one goes in here. We, in Tina, need to make sure that our cable connections are really specific because it's a software that's really sensitive towards cable connections. So if you connect or mistakenly connect a component, it's very punishing. So we need to make sure that everything's correct. Now, what I did here, this current will be the one that's flowing through this resistor into this resistor. But I cannot just set this parameter like in here, because being a current, it needs to be like in the real life connected in series with the one that we're measuring. So we make this connection. Again, we make sure that it's correctly done, because if not, the value that it's going to drop is going to be incorrect. And finally, we draw this connection. Again, making sure that it does not intersect with the one that we make flowing here. This one's okay, and this one's okay. So I think that we have closed now our circuit. Finally, we need to identify each and every node we have in here. We can notice that this could be one node, this is another one, this is another one, this in the center is another one, the one that's flowing in here is another one, and finally we have this one. This is the one that my team and I selected as our ground or reference node. So we search for the ground icon and we select it towards our reference node. And I think we're all said and done. I think we can start off by measuring. We go to meters and we select this icon. This is the voltage pin that's going to be representing every voltage. Every node we have. We're going to set everyone in every node. This one can be set here. Oh, I'm going to delete this one for a reason that I'm going to show now. And I'm going to delete this cable. And for measuring current, we can select this icon, that's current arrow, and we select it facing the direction we need the current to be going. So this one's going to be down. Now, why did I delete this one and why did I delete the cable? Because again, this is a current that should be connected in series. So we need to be really careful with making this connection because again, this is a very sensitive software. Yeah, it's correct. This is correct. Finally, this is correct. And now we can set our voltage meter. If everything is correct, we should be going to analysis. We should be going to DC analysis. And either of these choices will be showing the complete table of results for every pin or current pin that we selected. And it's okay. We can see, our voltage, our nodes voltages. And we can see that it coincides with the voltages that we set. I'm going to make this big. On our nodal method technique when we solve this circuit by hand. So yeah, that would be it. This shows that it's a really good approximation. And yeah, that's it. Thank you.